Hey, I'm Thomas Zurbuchen, the head of science at NASA, also known as Dr. Z.
And I'm Ellen Stofan, also known as Dr. E. Welcome to another episode of Easy Science. So Thomas, we're here at the Stephen F. Udvar-Hazy Center in Chantilly, Virginia, at the tail of the Discovery Space Shuttle, because we're celebrating a very special anniversary.
That's right. I just talked to my kid who just started college. He's 18 years old, and astronauts have been in orbit for his entire life. There has been an American in the space station and in international partners during the same time. For 20 years, the space station has been inhabited, and what an amazing anniversary of international cooperation. This 6-bedroom building up there, the length of a football field or so, inhabited and doing science.
It's incredible. We feel a really close connection to the International Space Station because about a third of Discovery's missions were helping to construct it. You know, there's modules on the space station from the United States, from Japan, from the European Space Agency, and Russia. And it's such a great example of international cooperation, how even though sometimes we don't get along here on the ground, we can literally go to a higher plane and find a way to cooperate.
That's right, 240 astronauts from 19 countries, nearly 3,000 experiments, and many of them, of course, on the inside. But we have multiple experiments from 3 disciplines hanging from the outside of the space station. I'll pick up one. The structure of neutron stars. The internal structure of that is measured by the NICER experiment. And that is right now taking measurements of X-rays in the sky from the space station.
That's amazing. And you know, my favorite experiment actually has to do with human health. And I think a lot of people don't realize how much research has been done on the International Space Station around human health. You know, almost half of the Apollo astronauts either got an infection in space or got an infection soon after they returned, because what we've discovered is that when you put humans in microgravity, their immune system doesn't function as well. And we've actually done enough experiments on the International Space Station to realize it's the T-cell part of your immune response in your body that's being suppressed. Now, that's fascinating because we can use that information to better understand how our immune system works. And obviously right now in the time of COVID, that's really important information.
The other thing that I think about a lot is, and I actually talk to astronauts about it who have been up there for substantial times, is the importance of this experiment called Veggie. It sounds just like what it is. It's actually growing plants in space. And what's really exciting is for them, we know psychologically that's really an important part of a livable environment, to have plants, green, that lives there. And frankly also that they can eat. And they love especially some of the very spicy plants that are out there. But a lot of research is being done with these plants to just really learn how, of course, as we prepare for longer duration travel, how we can use that kind of platform to grow food and to have that livable environment.
Yeah, it was funny when I talked to Scott Kelly after he came back from his year in space. He talked about how much growing flowers in space, how much that meant to him in that long year that he was up on the International Space Station. Which reminds me of one of the most important things we use the ISS for that we haven't mentioned. This whole issue of learning to live in space is critical for getting humans not just back to the moon, but on to Mars. It's that 7-month journey to Mars, time on Mars, time back. The International Space Station, we've been using it as a platform to get humans ready, to get our technologies ready to go further out into the solar system.
That's exactly right. There's a number of experiments going on right now on the space station that are really about life support systems that we want to use to go beyond, go to the moon first as part of the Artemis program. And of course, we have one eye on Mars already because, of course, robotically, we're on the way there with Perseverance, but with humans, we want to follow and go there also. And yet, the space station will forever be in the history of that because the technologies were really developed right there.
The ISS has been an incredible platform for student experiments. So every year at any given time up on the ISS, there are experiments going on that were sent up there by students, high school students, even elementary school students at one point, college students. It's an incredible platform to let students get that first understanding of how does science work? How do you design an experiment? How do you get a result and what do you do with it?
That's exactly right. And for me, kind of when I think of the space station, I think of it as a victory of the human spirit and the coming together as the Earth as one, explore as one, both on the human side, but also the scientific side. So I just really want to congratulate the entire team that has been part of that building it, but also during the entire 20 years running this highly complex machine internationally. And I look forward to everything we're going to learn in the future as well.
It's an incredible success, and we can't congratulate enough the International Space Station team and all the countries, the European Space Agency, Russia, obviously the US, and Japan, who've been the key core part of the ISS team. Well, I think we're just about out of time. Thank you for joining us for another episode of Easy Science.